video for measurement and problem solving. And then the next set of slides, and I fixed the slides, but the next set of slides will have will just be more problem solving and more practice for you. So I left off here. So remember, sig figs only apply to measurement. It's not always obvious if something is a measurement or not, but these are some general rules. So now we're going to deal with sig figs in calculations. So it is important to know how to round things, and I wouldn't lose a lot of sleep over this, because by the rules of sig figs, that last number is a guess. So if the right answer is 34.5 and you say 34.4 or 34.6, those are all the same number by sig figs. However, just to be consistent, because someone spent a lot of time on this, right? When you're all done, you have to round it to the correct number of sig figs, because if you're supposed to have 3 and you give me 4, you're lying because you weren't that precise. So you can go through this slide. Whatever you've been taught about rounding, I would just say do that and be consistent. If the number you're dropping is 4 or less, you just drop it. And if the number you're dropping is 5 or more, excuse me, you raise it. Right? Now, the bottom line when you do operations in significant figures, when you're doing calculations, is that you're only allowed one guess in the answer, and so you have to cut off the answer after the first guess. Now, when you read this in the textbook, it's going to use different words, and it's going to seem much more complicated. They say something like, the highest level of uncertainty or whatever. But if you just line up the digits and see where the first guess is from the left, cut it off there and then round appropriately. Very interesting that the number of significant figures can change when you add and subtract. All right, so looking here, we're going to add up these 3 numbers. So this number has 3 sig figs. This number has 3 sig figs. This number has 4 sig figs. I put arrows here for the last sig fig. Right? The 4 here is a guess. Excuse the dogs. The 3 here is a guess. The 1 here is a guess. So when I add these up, you see how I have a guess. The 1 and the 4 are guesses, but I only get one answer. I only get one guess. I'm only as precise as my least precise measurement. So I have to cut off my answer to the decimal place, which is the hundredths place. So 9.21 is a more correct answer than 9.214. And I know that's counterintuitive, because all your life you've been taught more digits is better, more digits is better, more digits is better. But it's not. If you wrote 9.214, you weren't that precise. You're saying that you're guessing this number, but you're actually guessing there. That's why it's really important. Okay. Again, this is just with a subtraction, and this is a good example. See how this number has 2 sig figs and this number has 4? So when we do the math here, I line up the decimals, and then I put the 8 as a guess, the 5 is a guess, the last significant figure is a guess. So once again, look at this. I have 2 guesses. I have to stop after the first guess. That number here, anything after that is trash. It would be a lie. So see how I had 2 sig figs, 4 sig figs, but my answer only has 1? That happens when you add and subtract. So adding and subtracting, just keep track of where the guess is, cut it off after the first guess, round appropriately. Okay. Multiplication and division is actually the same rule, but because we don't multiply and divide by hand, it's just much harder to see it. So it's best to do it this way. You just round it to the fewest number of sig figs. So the result will be whatever the least number of sig figs is. So, for example, here this number has 3 sig figs. The 89.665 has 5. 0.10 has 2. Why does it have 2? Remind yourself. This 0, if I cover it up, is it a placeholder? No, it's the same value. Also, it's after sig fig and after decimal point. All right, so my answer, my calculator says 45.0118, but my calculator is a liar. I only get 2 sig figs. 45 is a more correct answer. Same here with the division. Multiplication and division are really the same thing. Right, 4 sig figs, 3 sig figs. My answer gets 3 sig figs. All right, now, sometimes you have mixed operations and then it gets tricky. So you have mixed operations, and this is a brief example. I'm going to do other examples as we progress, and the next set of slides when we're just doing a bunch of problem solving, you'll see some. And the bottom line is to find a way to keep track of your last significant figure. When I do it by hand, I sometimes draw an arrow over it like I did back here. here with the arrows to indicate the last sig fig. Sometimes I put them in a different color. It depends on what I'm doing. Doesn't matter how, it matters that you keep track of it. So because we have addition, subtraction, in this problem here, we have addition, subtraction, and multiplication, division. This number sig figs can change when I do this operation. I can't go, oh, this has 4, and this has 3, and this has 2. My answer will have 2. It might not. I have to keep track of this. All right. So what I did is I put the last significant figure for each one in red. Since this is in parentheses, I'm going to do this subtraction. Now, when I do this subtraction, I have a guess in the hundredths place and a guess in the tenths place. So my last sig fig is actually in the tenths place. So I actually have 2 sig figs. A good rule to go by, keep one extra digit and then round at the end. The reason is rounding errors will tend to cancel, but sometimes they don't. So you keep the 1 extra digit and round at the end. All right? So now we know we have 2 sig figs. So now we're going to take the 3.489 times 3.37. This has 4 sig figs. This only has 2. That means I'm multiplying, dividing. My answer will have 2, right? So I'm putting the last sig fig in red. So that means I'm going to call this 12. And again, 12 is a more correct answer than 11.758 because 11.758 has some, bullshit numbers. These were not measured or guessed. This is my guess. Anything after that, useless. All right, I believe that's the last slide. So that is the last video for this unit. There's homework over this, but I have one more set of slides and videos to get some more practice with the problem solving, and we're going to do some problem solving in our synchronous meeting, based on your schedule.